Oh my goodness. Okay. This Zoom session is being brought to you by the fractal Almond Octaves Z. All right, fine. A brief one here today. The cross product. It has some connection to trigonometry. Not much as a sine theta involved. Mostly this is about vector algebra. So yeah, let's go through this. Here we go. Cross product 5-7. Last section of the class of the book. There'll be let's see. Okay, so cross product. Here we go. It's for 3x3. It's for three-dimensional vectors, three components: v1, v2, v3, w1, w2, w3, and the cross product is this: v2, w3 minus v3, w2, v3, w1 minus v1, w3, v1, w2 minus v2, w1. What it looks like is a 3x3 determinant. Okay, for where I, j, and k are unit vectors. So here you go. I times v2 w3 minus v3 w2, j minus j times v1 w3 minus v3 w1 plus k times v1 w2 plus w1 v2. Okay, it's can be thought in terms of three-dimensional space. Well, it's a three-dimensional thing, so this is not a really good picture being flat. But imagining v in one direction, w in another direction, v cross w is at right angles to both of them. Use what's called a right angle rule. Moving from this to this, the thumb points in the direction of the cross product. It's perpendicular to both, and the length is the area of the perpendicular parallelogram with sides v and w. So its length is length of v times length of w times sine of the angle between v and w. So, okay, it has various rules. Okay, unlike dot product, it gives you a vector given two vectors. So it's really a little bit more like a vector than the original was, than dot product was, because it turns vectors into vectors. But only three vectors into three vectors. It doesn't work for 2 or 4 or another dimension. And it has some odd rules. One is that a vector cross itself is always a zero vector. And also a vector cross v dot w is the opposite of u dot v is the opposite of v dot u. This implies that the vector cross itself is zero because it's the same forwards as backwards, and therefore it has to be its own negative, which is zero. And it's a form of associative. Alpha times u dot cross v equals alpha u cross v. So it's a kind of associative, and it's a kind of distributive. U cross v plus w equals u cross v plus u cross w. All right, fine. So that makes it handy because it is very much is rather like a product, and so you can have many of the usual rules. Cross products are useful, well, all over the place, really, in physics and engineering. You define Maxwell's equations for electromagnetism uses the cross product. It has a differential operator cross the magnetic or electric vectors. It tells the curl of a vector field. We'll let that pass. Okay, so some examples. So okay, we're using a 2x2 matrix determinant. 3 times 2 minus 4 times 1 is 2. So they ask for that. And here we have a 3x3 vector, 3x3 matrix, and you expand along the top row. A times this determinant minus b times 1, 5, 5, 2 determinant plus c times negative 1, 3, 5, 0 determinant, which after evaluating each of these is minus 6a plus 23b minus 15c. All right, so here we have this vector. V is 2 by negative 3 by 1, w is 3 by negative 2 by negative 1. What are their two cross products? Okay, we have two of them. Two are v dot v, which is 0, and w dot w is 0, so that's obvious. Here I ask also for v cross w and w cross v. These are opposite, so once we have one, we'll have the other. So v cross w, ijk times 2, negative 3, 1 second row, 3 minus 2 minus 1 third row. So I times this determinant, minus 3, 1 minus 2, 1. So it's plus minus plus, so it's a minus j times 2, 1, 3 minus 1, like that. Plus k times 2 minus 3, 3 minus 2, like that. And after some work, it's minus 1 by 5 by 5. And V cross W, so W cross V is the opposite. So therefore, 1, negative 5, negative 5. Here they ask for a curious thing, a dot product with a cross product, which turns out to be the volume of the parallelepiped spanned by these three vectors. For that later. Because this has a length equal to the area they span, and it's perpendicular to both. A dot product will be length along that perpendicular times this thing's area, and that gives you a volume. All right, so here, 2, negative 3, 1 dot, negative 3, 2 cross 1, 1, 3. Okay, well, after some arithmetic using determinants or whatever the formulas, what have you, it's this cross product is 7, 11, negative 6. Dot 2, negative 3, 1 is easy. 2 times 7 plus negative 3 times 11 plus 1 times negative 6, which comes out to a number, negative 25. I said it was a volume. It's a directed volume. It can be plus or minus depending on the handedness of the vectors. Okay, that's it for here and for now. And so I'm going to call this one done. And so with some reluctance, I'm about to stop share. Okay, I hope I can get back on Canvas ever, at least today. I have some homework to do, so I hope I can access it. But that is said, let's finish recording.